Here's a direct variation example. Remember, direct variation, k is really your constant variation or your slope. So y varies directly as x. So the first thing I'm going to do is write the equation y equals kx. And it says y is 16 when x is n. So I'm actually going to plug that into the equation. So if y is 16, so let's plug in 16 for y. And then it says when x is n. So I'm plugging in an n where the x is at. So that's one equation. And then it goes on to name another scenario for this exact same equation. So it also says when y is n, so I'm going to plug in an n here for y. So y is n when x is 4. So I'm plugging in a 4 for x. So they gave us enough information to figure out the value of n. And here's how we could do that. So we're going to start with this equation here. And notice that in order to solve for n, you can't do it because there's two different variables. There's the n and the k. So we're going to have to use the other equation we wrote. And I know what n is equal to. It's equal to k times 4. So I could plug that in right here for n because n is the same as k times 4. And if I do that, I would only have one variable. So I get 16 is equal to k, and then plugging in k times 4. So now this is 16 equals k times k is k squared. So I'm just going to write this as 4k squared. Divide both sides by 4. So we get 4 is equal to k squared. And then take the square root of both sides, and you get k is equal to 2. All right, so now that we know k is equal to 2, I could solve for n. I could use this equation right here because n is equal to k times 4. And now that we know what k is equal to, it's a 2. So 2 times 4, 8. So n is equal to 8.